Alright, geometry, this is your last video. We are going over our trigonomic ratios worksheet. Hopefully the videos you watched were helpful, but I will reteach as we go over these, and so there'll be a couple that I'll kind of go over in great detail, and then we're just going to kind of get to the answers, and you can reach out to me if you have questions. Alright, so let's get started. Alright, so I don't know if you've ever heard the story. This is called Sohcahtoa. It was an old Indian wives' tale, and there's a story about it has corn, and I can't remember the whole story. You can make up a story, but Sohcahtoa is a term I honestly still think of when I think of trig functions, and it stands for the sine. Now let me change my marker here. The sine function, which is represented with just S-I-N, but the whole thing is spelled sine. So the sine is the opposite over the hypotenuse. Okay, so S-O-H. The cosine, which is spelled this way, or written as the cos, like this, is the adjacent over the hypotenuse. I'm going to start abbreviating here. All right, let's make this a little bit smaller. Okay, and then the tangent of some angle is equal to the opposite over the adjacent. All right, so hopefully you practice a little bit of those. Let's put some of these into practice. So we're going to have to look at what angle we're looking at, identify which sides are opposite, which is the hypotenuse, which is the adjacent, and then we just literally write it as a ratio there. Okay, so there's our Sohcahtoa. Let's start looking at this first one. The first one we need to do is find the tangent of Z, is how we would read that. So here is our angle. You've got to identify your angle first. So let me pick a color here. Here's my angle, angle Z. And if you remember, the tangent of some angle is equal to, see if I get my colors right, the opposite over the adjacent. Sohcahtoa, so you can think of toa. The tangent is the opposite over the adjacent. Okay? So in order to identify these, we've got to look at this angle, because the opposite and the adjacent are always going to kind of rotate and switch around. Hypotenuse will always be the same, but your opposite versus your adjacent could be different depending on which angle. So if this is my angle Z, the opposite angle is the one across from it. And the adjacent means next to or touching, is the one that touches that angle. So this is my opposite. So 21 is my opposite, and 28 is my adjacent. But this isn't simplified. I can take this fraction and I can simplify this. I could divide both by 7 and I would get 3/4. So 3/4 should be the answer to the first one. There you go. That is all you have to do. It's as easy as that. So of course this here would be your hypotenuse. Opposite is across from the angle. Adjacent touches the angle. All right, so let's look at the cosine. Cosine of C. So let's identify our angle. There's angle C. All right, the cosine, Sohcahtoa. Okay, so come back up here. The cosine is the adjacent over the hypotenuse. Okay, adjacent. Oops. Now we always know the hypotenuse is the longest side length that's going to be across from your right angle, because right angle has to be the largest angle in a triangle. All right, what color did I use for this? So yellow. All right, adjacent. All right, adjacent means touching. So I need this side over here. It's the one that touches the angle and is not the hypotenuse. So in this case, that would be a 16, and my hypotenuse is 34. See, I could just divide both of these by 2. I don't think I could do anything else. That gives me 8/17. That's my answer for this one. The cosine of angle C is equal to 8/17. could write it like this as well, right up there. Okay, well, let's do a sine one. Okay, the sine of C. So here's my angle, C. The sine is equal to, I think it's red. Let's see, yes, okay. Sohcahtoa, opposite over hypotenuse. All right, so the opposite has to be across from that angle. So in this case, my opposite is 28. If I had the sine of angle A, the opposite would be 21. But take your angle, draw an arrow out. Now the hypotenuse again is always across from the right angle. It is the longest side of your triangle. And now in order to write this in full form, I'm going to simplify this. And what could I divide these by here? Okay, I think I could divide and get 4/5. Is that right? Okay. 4/5. The sine of angle C is equal to 4/5. All right, we're going to go a little bit quicker through the rest of these. I did one of tangent, one cosine, and one sine. All right, so here's the tangent of angle X. So angle X is down, wrong color, angle X is down here. The tangent is the opposite over the adjacent, that's touching without being the hypotenuse. Okay, so 24 is in the denominator, and the red side is 32 in length. Okay, so 32/24 can definitely be simplified, and that should give me 4/3. So the tangent of angle X is 4/3. All right, let's do the cosine of A here. So cosine, remember, go back up to your rules here, is the adjacent over the hypotenuse. The only one that doesn't use the hypotenuse is tangent, right here. Okay, the other ones always use the hypotenuse, sine and cosine. So identify your hypotenuse. And I want to have the adjacent side, that's the one that touches. Cosine. Sohcahtoa, right? So it's the adjacent over the hypotenuse. Adjacent's the one that touches it. So we're going to have 30/34. I can definitely simplify that down. So the cosine of A is equal to 15/17. I can just cut those in half. All right, number 6. The sine of A. Here is my hypotenuse. It's across from the 90-degree angle. And in this case, I'm sorry, I forgot to mark my angle. Here's angle A. In this case, I want to have the opposite, Sohcahtoa. The opposite is across from that angle. So in this case, it would be 32/40. And when I simplify that down, I would get 4/5. So the sine of A is equal to 4/5. Okay, I hope I'm not going too quickly through these. If you need to pause the video and see, again, I'm just kind of assuming that simplification here is simple. Don't forget, if you do it to the top, do it to the bottom. In this case, divide by 8. All right, the sine of Z. Here's your angle. The sine, we just did one that was sine. The opposite over the hypotenuse. Hypotenuse is your long side. The opposite is across from your angle. So we have 24/40, and we can simplify that down. What could go all the way down to 3/5, right? All right, sine of Z is equal to 3/5. And go ahead and leave it as a fraction. You don't need to make them decimals. All right, sine of C. So here's my angle, angle C. The sine we just did again is opposite over hypotenuse. The hypotenuse is across from your 90-degree angle. It's your longest side. So it's a 50, and in this case, the opposite is 14. So I could divide both of those by 2, I guess, and I would get 7/25. So the sine of C is equal to 7/25. All right, 2 more, and then we get to pull out our calculator here. Cosine of Z, here is my angle, angle Z. The cosine is going to use the hypotenuse, but you need to have the adjacent side as your numerator, and adjacent is the side that touches 24/30, and I can simplify that, so the cosine of Z is equal to 4/5. And last but not least on this side, the tangent. Tangent is equal to the opposite over the adjacent. So here's my angle C. Opposite is across from it. That's this side right here. And I'm not going to use the hypotenuse this time. I'm going to use the adjacent side, which is right next to it. And I can definitely simplify that as well. So the tangent of C is going to be equal to 3/4. All right, for this section, because the directions previously stated find the ratio, we want to leave it as a fraction, a ratio of the numerator compared to the denominator. But now that we want to have the value of it, that means I'm going to make it a decimal. So we're going to do the exact same thing we did before, but we're going to make it into a decimal. So for the cosine of Z, we have to find our angle. And we know that cosine is the adjacent over the hypotenuse. Hypotenuse is 15. The adjacent is 12. So I could take 12/15 and just simply divide that into your calculator. Now looking at this, I know I could simplify the fraction a little bit, but really no need to. You can just take 12 divided by 15, and we're going to get a decimal. Plug that into your calculator, so the cosine of Z is equal to approximately 8/10. Now it says to the nearest 10,000th. That means 4 numbers after the decimal. So if there's nothing else, I'm just going to have to put zeros in. Okay? All right, number 12. The cosine is the adjacent. Did I use blue? Or yellow? Okay, it is yellow. I keep forgetting. Adjacent over hypotenuse. All right, hypotenuse, the longest side, across from the 90-degree angle. In this case is 45. The adjacent to my angle C is touching it, 27. In your calculator, take 27, divide by 45, and so the cosine of C is equal to 6/10, but because we want it in the nearest 10,000th, we just have to add 3 more zeros. All right, tangent of C. The tangent of this angle here is the opposite over the adjacent. You should be able to see this as 4/3 very quickly, and so when you divide that, you know it's got to be larger than 1. So the tangent of C, 1 1/3 really, or 1.3 repeating. Now, we don't want the repeating symbol because it asks us to round to 4 numbers after the decimal, and so really there would have been a 3 here, which means this doesn't round up, so we can just say 1.3333. Okay, the tangent of A, here is angle A. The tangent is the opposite over the adjacent. So the adjacent here, now careful, why is this one not here? Not the adjacent? It's because it's the longest side, so that would be the hypotenuse. So don't be confused by that, because technically they're both touching, but we want to use the adjacent that is not the hypotenuse. And the opposite angle over here is 21. And you'll only really run into that when you're doing tangent, because otherwise you'll be using the hypotenuse and it'll be clear which one is your adjacent. Okay, so this one's clearly a little bit more than 1. It's going to be 1 1/20th, which actually, if you think about 1/20th, 1 nickel is 5 cents, and there are 20 nickels in $1, so this should be 1.05. Or you can just take into your calculator, take 21 divided by 20. So the tangent of A is equal to 1.05, and remember we need 4 numbers after the decimal. So add those zeros. All right, tangent again. So we're going to have the tangent of C is equal to the opposite over adjacent. All right, so here's my hypotenuse. I'm not using that, but I'm identifying it when I do tangent so that I don't use that one. Okay, so the opposite of angle C, here's the angles that we're looking at. Remember, if you use the wrong angle, you're going to have everything inverted or backwards. So the opposite side over here is 12. And the adjacent side, which is next to that angle or touches that angle, is 35. Take 12 divided by 35 in your calculator, and you're going to have a number that's repeating forever and ever. We're just going to round it to 4 numbers after the decimal, 3429. Tangent of C is equal to 0.3429. Okay, tangent of X. Here's my angle. I'm going to mark the hypotenuse so that I don't use that, because for tangent I just want opposite over adjacent. The adjacent side touches the angle, so that's 40. The opposite side is across from it, which is 30. So I know this one to be 3/4 or 0.75, and add 2 zeros because we want it to be rounded to the nearest 10,000th. So the tangent of X is equal to that. All right. Away from tangent, the sine, back to using my hypotenuse. And I want the opposite over the hypotenuse, Sohcahtoa. Here is my angle, angle Z. So the opposite, the hypotenuse will always be the hypotenuse. The opposite just depends on which angle. And so if it's angle Z, it should be across from that. So it's going to be 12 over 37. When you plug that into your calculator and divide that into a decimal, we'll get the sine of Z is equal to 0.3243. All right, number 18, sine of Z. Here is my angle. Hypotenuse is the longest side. We already know that. The sine is the opposite over the hypotenuse. So the opposite of angle Z is 30. So this should be 3/5 or 0.6. Sine of Z is equal to 0.6, and add your zeros just because of what it asks us to round. You wouldn't have to do that every time. Okay, now it's giving us some degree measurements, and there's really no triangle here. So all you have to do is plug this into your calculator. And so I can't show you my calculator on here, unfortunately. I might actually try to insert a picture in a little bit, but you're going to need to make sure you're in degree mode. So let me show you how to do that. So on your calculator, you are going to want to make sure that you are in degree mode. So push your mode button, that's right here. And if radians is selected, let me zoom in here a little. I guess I can't zoom in anymore. If you have radian highlighted black, you want to scooch over with your arrow button and make sure that you hit enter, and then make sure that it says degree mode. Okay, otherwise you're going to get a different answer even if you type everything in perfectly fine. Then you can just do second quit, here second, and then do mode button again, and that takes you back to your regular screen. And then you should have your sine, cosine, and tangent buttons. They're above the 7, 8, and 9, 2 up from that. All right, so all you need to do in this case is type in sine 48 and hit enter. So it should look like this, and because we're going to round it to the nearest 4 after my decimal, I'm going to just use these right here. Oh, I'm not in draw mode. There we go. All right, so the sine of 48 is going to be equal to 0.7431. Now, if I needed to round, I would. All right, cosine. Now that you're in radian mode, just plug this in, hit enter, and you should have 0.04848. That was 21. I know I skipped 20. Sorry, here we go. Here's the sine of 38. Plug that into your calculator, hit enter, and you should have 0.6157. And for the cosine of 51, you should get 0.6293. Now, if you're typing these into your calculator and it gives you a different answer, it's just because of you're probably in radian mode because of that difference there. So please just check that. All right. So can the sine of it, these are just bonus questions. You didn't have to answer these, but can the sine of an angle ever equal 2? Well, let's think about that. If the sine is equal to the opposite over the hypotenuse, and this has to equal 2, that means this is 2 over 1, or the opposite angle has to be larger than the hypotenuse. Is that possible? No, hypotenuse by definition is the longest angle, so no. It can't, because a side length can't be longer than the hypotenuse. All right, and if you had the sine of x equaling 1/3. This is just for fun if you are wanting to know this. May not be fun for you, but hypotenuse, for sine, it's the opposite over the hypotenuse. So we know that we have some sort of a triangle. We know that hypotenuse is 3, and here is angle x, and we know that the opposite side is 1, and so we would have to find this missing value right here to find the cosine, because the cosine would be adjacent over hypotenuse. All right, so we would have to use the Pythagorean theorem to find this missing side length here, and we could say that 1 squared plus x squared is equal to 3 squared. A squared plus b squared equals c squared. Okay, so x is equal to the square root of 3 squared minus 1 squared, or x is equal to the square root of 9 minus 1, or the square root of 8. All right, now we know the square root of 8, you could turn this into 4 times 2, so I could have 2 times the square root of 2. So 2 times the square root of 2 is most simplified form, and I could plug that into this side. So now I know that this side is 2 times the square root of 2. So to find the cosine of x, I need to find the adjacent over the hypotenuse. And if this is my angle here, the adjacent side is next to it, and the hypotenuse is over here. So the cosine of x would be equal to 2 times the square root of 2, and the hypotenuse is 3. All right, if you did not fully follow that, that's okay. That's just a challenge question. If you did, way to go. This was a hard problem, but very easy to find all of the other sides once you have the information you have in terms of steps. Maybe a little mathematically hard to figure out with the square roots there, but I hope this helped. Please let me know if you have questions, and enjoy the rest of your summer. Make sure you take your assessment online and give me your feedback. You're getting credit for giving me feedback. It's going in as an assessment grade, just if you did it. So make sure you take care of that, and I'll see you later.